So we discuss about quadratic equation. So in chapter 2, quadratic polynomial, you studied p of x is equal to ax square plus bx plus c, a not equal to 0 is a quadratic polynomial. In chapter 2 you learned. If we take this p of x as 0, that is p of x equal to 0 means ax square plus bx plus c is equal to 0, a not equal to 0 is a quadratic equation. Means the values of x make this complete polynomial 0 is the solution, or when can you say this quadratic polynomial value of this quadratic polynomial becomes 0? Such cases, such equations we are saying quadratic equations. So example, x square plus 5x plus 6 equal to 0, x square minus 3x plus 2 equal to 0, etc. Then the values of x satisfies the equation, the root. Root is also called the solution. Here you may see that if x is equal to minus 2, if I am putting here in LHS, you will get RHS. You see minus 2 square plus 5 into minus 2 plus 6 is equal to 0. So we can say x is equal to minus 2 is a solution or a root of this equation. The nature of the root. Nature of the root means what type of solutions or roots you may get from a quadratic equation. It depends upon the discriminant. What is the formula to find out the discriminant? D is b square minus 4ac. D is equal to b square minus 4ac, where b is the coefficient of x, a is the coefficient of x square, and c is the constant term. Now, if d is equal to 0, this b square minus 4ac value is 0, then the roots are real and equal. You will get real roots as well as equal roots. So as we learned in chapter 2, quadratic polynomial is a parabola. So quadratic equation also, if you are drawing the graph of such a polynomial, this polynomial if you are drawing, then that parabola will cut x-axis. Will cut, touch x-axis. If roots are real and equal, then touch the x-axis, which you learned in chapter number 2, touching. If d greater than 0, then roots are real and distinct. If we are drawing the parabola, in that case, it will cut x-axis. If d less than 0, then no real roots, parabola will not touch or cut x-axis. Means because this is a parabola. So it depends upon the nature whether if the graph of the parabola is touching or cutting on x-axis. That depends upon d. Some of the example is written here. X square plus 2x plus 1 equal to 0. Here you may see that a equal to 1 coefficient of x square, b is equal to 2 coefficient of x, c is equal to 1 constant term. If I am finding d, then you will get 0. Root is, you will get only one root, that is minus 1. No other root you will get. That is, if you are putting x equal to minus 1, you will get LHS equal to RHS. Similarly here, x square plus 5x plus 6 equal to 0, a1, b5, c6, you will get discriminant 1 which is greater than 0. So roots are, so two distinct roots you will get, they are minus 2 and minus 3. We are solved. How to solve that we will study just now. Then x square plus x plus 1 equal to 0, a1, b1, c1, d is equal to minus 3, you will get no real roots. Now let us see how to solve a quadratic equation. Methods of solving a quadratic equation. There are two methods you are learning. One is factorization method by splitting the middle term, which you learned in early classes. Here x square minus 5x plus 6 is equal to 0. You will find out two numbers whose sum is minus 5, that is coefficient of x, and product is the constant term into the first one, which you learned in early classes. So you will get the solution as x is equal to 2 and x is equal to 3. You may check it is correct or not. One of the root is alpha and other root is beta. Alpha equal to 2, beta equal to 3. So sum will come 5 and product will come 6. And how to make the polynomial, you studied p of x equal to x square minus sum of the root into x plus product, x square minus 5x plus 6. That's a polynomial. If we want to make it as quadratic equation, instead of p of x you put equal to 0. You can verify those. Second method is formula method. The formula is x is equal to minus p plus or minus root d upon 2a, where d is the discriminant, b square minus 4ac. Example, x square minus 5x plus 6 is equal to 0. A equal to 1, B equal to minus 5, C is equal to 6, 1 minus 5, 6. Discriminant is 1, which is greater than 0. 2 roots you will get. That is my formula I am applying. X is equal to minus B, minus or minus 5, that is plus 5. Plus or minus root 1 divided by 2. Root 1 is D. Simplifying, you will get 3 or 2. Same root which you used in the previous one, that is here. Same is written here. Another example is x square to root 2 x square plus 7x plus 5 root 2. Here a is equal to root 2, b is equal to 7, c is equal to 5 root 2. If you are finding discriminant, you will get 9. And x is equal to minus 7 plus or minus 3 upon 2 root 2 formula I am applying. You will get the roots as minus root 2 and minus 5 upon root 2. Let us see some of the important questions which are always coming in the examination. Well, the type of question. So find P, yeah, K, whatever it may be. If an equation has equal roots, means real and equal roots, then D is equal to 0. That's the most important part. D equal to 0 means real and equal roots. What is happening, D equal to 0. So I open this bracket, then I find out ABC. Then D I find out. D you are getting as 9p square equal to 0, not 9, that is equal to 0. This is equal to 0. You will get two values of p, 9p I took it common outside, p equal to 0 or p equal to 4. P cannot be 0 because if you are putting p equal to 0 here or here, then no quadratic equation is there. So value of p is 4. Similarly, another question is written here. A is p plus 4, b is equal to p plus 1, c is equal to 1. Discriminant I find out is equal to 0. Simplifying, you will get a quadratic equation in p. So I factorize, or you may do by discriminant method also, means formula method also. Middle term split, sum is minus 2, product is minus 15. So I split the middle term. I got two values, p is equal to 5 and minus 3. Both are possible. Because no problem with the minus 5 or minus 3 here, because this is always not 0 whenever I am putting 5 and minus 3. So both are possible. So these two questions are additionally written, not much important for board examination. Here you can find out only a relation. X square minus 2px plus 5 equal to 0 has real and distinct roots. So D is greater than or equal to 0. 4p square minus 20 greater than or equal to 0. I cancel the common factor. So I can write this much only. More than that you can do only when you are reaching 11th standard. Okay, so we will get it. If you want to take this 5 to right hand side, it's okay, just like in the next case. No real root, so less than 0 I will get p square less than 4. These first two types are important. Third and fourth is not that much important for your exams. Now let us see the word problems. That is very important for the examination. One or two word problems I will show you. There are two important word problems written here. One of that is related to day-to-day life. One of this is a passenger train takes 1 hour less than its speed when its speed is increased by 15 km per hour than its usual speed for a journey of 300 km. Means if the speed is increased, then time taken to travel the distance is less. Here it is given total distance to be travelled by the train is 300 km. If it is going by a particular speed, it will reach a particular time. But if the speed is increased by 15 km, automatically time will be reduced, that is 1 hour less. Then what is the usual speed? That's a question. It's one of the important type of question. So let the usual speed is x. Actually, this was actual speed to be traveled, but it is increased by 15 km per hour to reach the destination 1 hour earlier. That is the reason. So usual speed is x kilometer, distance traveled is 300 km per hour, and we know time. In this case, distance upon speed. In this case, time will be 300 upon x. Now, when the speed is increased, that means x 15 km increase. Earlier it was x, now 15 increase. So x plus 15. Then time taken, the second case will be distance same, 300 upon speed, x plus 15. Here you may say that this will take more time and this will take less time because the speed is increased. More speed, time taken will be less. So whatever the time taken here and whatever the time taken here, if you are subtracting, it will come 1 hour. Or if this way it is going, means in this time if it is going, then here whatever the time is taking plus 1 hour extra will come. If I am writing in the right side, then whatever the time required plus 1 hour is required for reach this one. That's the meaning of the question. So in simple way, you will see where the speed is less, that you write first. Where the speed is more, that you write second, and the difference you write as the given time. That's the best way. Simplifying, we get a quadratic equation. It is done with the help of discriminant method and 60 km per hour. I calculated. Similar type another question. Both of these questions are very important. Type of question. An aeroplane left 15 minutes later than its scheduled time. In order to reach the destination on time, speed is increased by 250 km per hour. If the distance traveled is 1250 km, find the usual speed. That's a question. It means actually the time delay is came at the airport. So where the plane to be traveled 1250 km. So actually whatever the time actually it should be started, so it is delayed by 50 minutes due to some of the reasons. There are flights are always delayed because of some reasons. So here it is 50 minutes delay. So to reach the destination on time, the speed is increased. How much speed is increased? 250 km per hour. Then what is the usual speed? Here also to let the usual speed is equal to x km per hour. Distance to be traveled is 1250 km. So in this case, time taken is 1250 upon x, just like here. Minus speed is increased here. 1250 upon x plus 250 is equal to 15 minutes. I converted into hour because both of these are given in hours, kilometer per hour. So I simplify it. Let's simplify. You will form a quadratic equation. This time use the factorization method. You can do by any method, and you will get x is equal to 500 km per hour.